ZONA-MV can be used to export zone data. So in this video we're going to show you an example of the different options that are available when exporting zone data from a loaded model. So first we will load a model that happens to be saved in Nastran bulk data format. Now when exporting data you can actually translate from one type to another, so it doesn't matter which one is loaded. So in this case we have a UAV type model that we can load, and here we see then that if we go to the zone settings button, we see we have 4 types of bulk data that are loaded. C-Quad 4 that's shown in red here, C-Rods that are in green. If we turn off the C-Quads we can see the C-Rods here. If we turn off the C-Rods, we can see in blue the C-Tria 3 or triangular type elements, and if we turn those off then we see the rigid body elements that are here as well. We have 7 of those. So turning it back on, now when we export the data we go to the export button on the home tab and click on that. It'll bring up the pane dialog for export, and we have 2 options here. In this video we're going to show you how to treat the zone data, which is the source data, this button on the left. So we have 3 formats that are available. We can output in terms of bulk data format, which is Nastran type of data. We can output in terms of TechPlot format, which is the FE point type of TechPlot output that is generated by all of the Zona CAE software, or STL format, which is allows us to output in triangle format. Stereolithography is what it stands for. And for this particular option we can output all of the zones in a single file, or we can output each zone into a separate file, which is useful if we want to keep the zone data separated. So first we'll just go ahead and start with the bulk data. Now granted this is already a bulk data model, but we'll show that when you export you can only keep the basic elements, which are the type 2, which are output as C-Rod elements, type 3, which are output as C-Tria, and type 4, which are output as C-Quad 4. So the RBE2 elements will be converted to C-Rod because this is just a generic bulk data output. Now if we have the grid checked, it will output the grid data. We have a button here to remove grids that are at the same location. So if we have that, the program can internally use just one grid for any elements that share a grid that's at the same location but different grids. So it'll stitch that up if we wanted that. Type 2, here we specify the element ID and PID. If we don't specify any element ID or PID for any of these types, the program will use the internal values. Now since we loaded a bulk data, those values will correspond to the original bulk data, which is probably what we would want. But if we loaded, for example, from an STL file originally, then it's going to number internally from 1 to the number of elements. So we can also use this as a conversion. So since we loaded a bulk data, if we wanted to change the starting element ID or even the reference property card IDs, we can do that here. So for example, let's say we start this one at 20,001, and we can just copy this into the PID as well. Let's say we start the triangular elements at 40,001. We can copy this over to the property ID, and let's say we start the C-Quad 4 at 60,001, and we paste this here. We also have an option here to reverse all the panel normals. So if you needed to do that, you could set this switch and all the orientation, in other words the order in which the nodes are output on each one of these elements, will be reversed. But we don't need to do that right now, so we'll just go ahead and export. We'll call this a Nastran bulk data, and we'll save that file. Now it's generated here, and we'll go over and take a look at the data that was generated. So if we look at this data, then we see it'll just dump out a begin bulk statement and output the CQuad4 starting at the ID, which we specified as 60,001. These are the property IDs, and these are the referenced grids for connectivity. So we can go down then after the CQuads. We have the CRODs, which we started at ID 20,000 and run, and then the CTRIA, which we started at ID 40,001. And then after the elements, it'll dump out the grid data on the bottom here. So these are the grid IDs and XYZ coordinates. And then at the bottom of the file, it'll terminate with an end data. So now we can load back into ZONA-MV what we just generated. We'll create a new ZONA-MV document, and then we will import a Nastran model, and this time we'll select the one that we just generated called Nastran bulk data and load that, and then we see the Nastran bulk data that we output. So this is the same model as what we started with here. And if we look at the zone settings, we see that we have the CQuad4, CROD, and CTRIA3, the three elements that are supported. So the next export option, we'll go back to the original file here, and we can export, instead of bulk data format, we'll export a tech plot format. And we'll just call this one tech plot with the extension PLT, which is the default extension for tech plot files. And then we'll go look at this file that's generated, and we see then it'll output a title with the date and timestamp. The variables are XYZ and external IDs for each of the grids or nodes. And then we have three zones. So the first zone is the CQuad4, and this is the number of nodes and the number of elements, and we save it in FE point format. So this is the standard format for Zona CAE software that's output, and where ZONA-MV stays consistent with that. So we have three zones here. The second one is the CROD, and then the third one is the CTRIA3. So that's the tech plot file, and now we can go back into ZONA-MV. We'll start a new document, and then we'll go back and import a tech plot file and load what we just generated here. And then again we get the model out that's saved, though this time in tech plot format, and this guy also has all of the zones specified. Since for tech plot we can also output the RB2s, there's no conflict, so it'll output exactly based on what was put in, except it's in tech plot format. So each zone had these names. Okay, so then the final zone data export option that we have is the STL, and we'll just go ahead, make sure we're back on the original data tab here first, and then we will output all of the zones in a single file within an STL file. So we'll export that, and we can call this one STL, save it. Now, one difference, STL files only contain triangular elements. So when you have these type of quadrilateral elements in your model, it will have to break each one of these down into two triangles. And of course, triangular elements themselves are output as triangle data. So here's the STL file, and if we look at this file, then we can see the vertex for each triangle that's output here, and then the normal vector for the panels. So this is just repeated for the entire model. So if we want to see what was generated, we go back to ZONA-MV, we add a new document here, go back to import, we choose STL file, and we load the file that we just generated called STL. And then we can see, if we take a little closer look here, that all of the quadrilateral elements were broken up into triangular elements. And the type 2 are disregarded because it can only handle type 3 or type 4 on a STL file output. So if we go to the zone settings, then we see that we have 36,507 triangular elements that make up this model. So those are the options that are available to export zone data within ZONA-MV.